Yeah, okay. Linear and quadratic systems. We'll read through this, pull out pertinent information. So Aiden threw a ball up in the air. The ball's path is represented by a function. You have some function. This is technically to the power of 2, where x represents the time in seconds. Arjun decides to release a ball into the sky at the same time. The ball's path is represented by another function. Both heights are expressed in feet. So what time do the balls cross paths? So this is an interesting question because essentially what they're doing is they're creating balls. Typically when they're thrown into space have 3-dimensional properties, but they're giving them 2-dimensional properties. So we don't exactly know where this is thrown. We don't know that Aiden's y-intercept is positive 4. It might do something like this. Okay, and then Arjun, on the other hand, looks like he has a y-intercept. Sorry, not a ball, but a balloon's path. So it has just a straight path. So it's going to do something like this. It's just a linear equation. So these two are going to cross at some point, assuming they're on the same plane. If we were doing 3-dimensional stuff, which is 2-dimensional, they would cross. So the question is, where do these two things cross? Okay, since x represents time in seconds, so this is the time, and the y-axis was representing our height. Okay, so the very first question is asking at what time do the paths and at what height above the ground are the paths the same. So essentially, what's the point of intersection? One is asking for the x, and this one's asking for the y coordinate of the point of intersection. So what we're going to do is we're going to set these two together. You'll notice they're both represented by f at x, which is uncommon. Usually you would represent a different function with a letter like g. Usually they'd call this something like g at x. That would be the name of a different type of function, but it's fine. They've called it y at x in this case. To simplify things for ourselves, if the function notation is confusing for you, we can always just rewrite the first equation here equal to y, because we're using the Cartesian plane. Our variables are x and y. So we could say y is equal to negative x squared plus 2x plus 4. And the same idea, we can write that linear one also as y is equal to 2x. So in other words, we have two functions. The number 1 we'll call our quadratic, and number 2 we'll call our linear. Luckily, they're both already set equal to y. So we can use substitution to solve this quite quickly, actually. I'm going to substitute the 2x value in for the y in equation 1. So when we go to do that, we'll get 2x is equal to negative x squared plus 2x plus 4. When I bring 2x to the other side, we're left with 0 over here, and we'll get negative x squared plus 2x minus 2x plus 4. If we collect our like terms in the middle here, we're left with negative 2x plus 4. And what's neat about this question here is we can very quickly get to the bottom of this one. I'm going to use a little bit of common factoring. I'm actually going to common factor out negative 1. And when we do that, we'll have 0 is equal to the common factor of negative 1. And then x squared minus 4. Here we have a unique quadratic. This is a difference of squares, this question. So because it's a difference of squares, we can say 0 is equal to negative 1, x plus 2, x minus 2. And just in case you don't quite remember difference of squares, we just square root the first term. We get its value, and that's the first term in both sets of brackets. Square root the second term. We take the positive value, and that's the second. Oh, that should be a 2. That's the second term in each bracket. Okay. Once we've done that, because it's set equal to 0, there's a rule in multiplication called associative property. And what that means is it doesn't matter what order we multiply things in, it's always going to be the same. To get to 0 when you multiply, you have to multiply by the number 0. There are no other numbers we know of where you can multiply and get a 0. Well, we know that negative 1 is not 0. In fact, if I divide the right side of the equation by negative 1, I can divide 0 by negative 1, and this negative 1 would cancel out. We'll just be left with the 2 brackets. So now we split these 2 brackets, and we're going to solve for them. So I'll do that towards the left bottom underneath the graph we've made. We're going to take the first one. We're going to set it equal to 0. 0 is equal to x plus 2. And I'll take the second one. 0 is equal to x minus 2. When we isolate for 2, we get at positive 2 Sorry, this one's -2, and this one's +2. Now, 2 answers, great. What that means is because quadratics go forever, technically here, and so do linear functions, we have a point of intersection here and a point of intersection here. The only thing is, remember what our independent variable or the x-axis represents is time. So for it to be at -2, that would mean before Arjun released his balloon, 2 seconds before they would have crossed. That's very improbable. In fact, really doesn't make sense, okay? And again, because our y-axis represents height, most likely this, where height is 0, we're talking about the ground. So it also wouldn't be 2 seconds ago underneath ground they'd intersect. So this one's a bit illogical. This is probably not the answer we're looking for. But this one, x at 2, is a logical answer. Since x is in seconds, 2 seconds after they release, 2 seconds after they released, the balloon and the ball would cross paths in the air. The second one, we just have to find the y value now. What's nice about this is since we're looking for points of intersection between 2 functions, I can take the x value, the number 2, and I can plug it into either function. I can plug it in the quadratic function, but the linear function is just so much easier to do that with. So I'll do it in green here just beside it. If we say g at 2 is equal to 2 times 2, we get a value of 4. So our height would be the value of 4. So we get a point of intersection of 2 and 4. So that means the height is at 4 and the time that it left is 2 seconds after the 2